Guys, do you have class at 7 o'clock?
Yes, sir. Chemistry.
Yes, sir.
Okay. Can we start in like 5 to 10 minutes? I have to take some medicines.
Yes, sir.
Just give
Sure,
me,
sir.
yeah. Thanks. Thanks. Thank you so much. Okay. Hi guys. Hopefully you guys are here. Sorry, I won't be a little louder. Cannot be louder more than this. Let me know if you are able to hear clearly. Okay. I'll share my screen. Let me know if you guys can see it. So we have finished coordinate geometry. All right. And that means a conic section was the last chapter of coordinate geometry. Today uh, we'll see a new chapter. Okay. And that is going to be limits. Okay. Limits and derivatives. First we'll have an idea of limit. So hopefully this chapter has been completed in school as well. And we'll try to understand what's the meaning of limits and derivatives. Okay. So limits and derivatives. And please let me know just stop me if we are just getting away from the topic. Okay. Just first let's understand, we have studied functions, right? Functions, we have studied real valued function, which is represented, usually we use f of x to represent a function, like f of x is equal to x square. That means it's a polynomial function of order 2. Okay, getting it? Hello, uh, are you guys there?
Yes, sir. Yes, sir.
Okay. Just keep responding. Okay, so this is a polynomial function. Okay, you have also seen trigonometric function. So since we have represented one function by f, let's write g of x is equal to, let's say, sine x. Okay, so sine x is another function. Let's say h of x is, now this is a trigonometric function, right? E to the power of x. So this is exponential function. We have several types of functions, right? And we will see one thing in common, that all the functions are continuous. Okay, all the functions that we see here, that's written here, is continuous for its domain. Domain, in short, is all the values of x where the functions are defined, right? We have studied that. And f of x will be its range or codomain, and we have studied that in functions. Okay, then what is limit? Why do we have to study limit? See, it's a really important concept in calculus, and it's very important. Okay, and it's exactly that simple as well. Okay, what we literally going to see here is that's what limit is. Okay, so we'll take example, we'll try to understand with the help of an example. Okay, so let's say there is a function f of x which is equal to okay, x minus 1 upon x minus 1. Okay, see, in so far what we have studied, that this function you can just cancel out and you can write 1. So f of x is equal to 1. Okay, but not so fast. Let's pause for a minute and think about it. Is it really 1? Just give me a moment. Give me a moment. I'm really sorry, guys. Okay, so is the function actually, that means f of x is equal to 1? Is f of x is equal to 1? Anyone? Can anyone tell me? See, because the numerator and the denominator are same, right? Same value. So is f of x is equal to 1? Let's substitute. See, for x is equal to 0, okay? For x is equal to 0, this function will become 0 minus 1 upon 0 minus 1. That is minus 1 upon minus 1, which is equal to 1. Okay, very good. Now let's say f of 2. Okay, so 2 minus 1 upon 2 minus 1, that is also again equal to 1. Let's say f of 100. So that will be 99 upon 99, that is again equal to 1. That means f of x should be equal to 1, is it?
Yes.
Yes, sir.
Okay, now let's find out f of 1. What are we getting? What is f of 1?
Undefined.
That means 1 minus 1 upon 1 minus 1, right? 0 upon 0. Now what is 0 upon 0? 0 upon 0 is not defined, undefined, right? Undefined. So this is a number which is not defined. Usually we represent by a symbol, infinity, but it's not actually infinity. Okay, it's just simply not defined. The function is not defined. Understood? That means this function is always 1 except when it is equal to 1. Okay, we can have other functions. First, let's try to plot this function. Okay, so how this function will look like? Okay, how this function will look like? Let's see. So this function was x minus 1 upon x minus 1. Let's see how it will look like. So let's try to plot it here. So this is our y and this is x, right? Y, x. Now for all values of x, the function is 1. The value of function is 1. Suppose this point, let's say this is 0, 1. So the function is 1 everywhere. Everywhere it is equal to 1, right? Except when the value of x is 1. If here x is equal to 1, right? So what happens here? The function is not defined. So that means here the value, let's zoom it. So here the value of this function is not defined. Okay, so we represent it wherever the function is not defined, we represent it by a small circle. Okay, like this. So at this point, at x is equal to 1, the function is not defined. You getting it? Understood? Yes or no?
Yes, sir.
Okay. Now just understand this part. So this is at x is equal to 1, somewhat around here, let's say. Now, what will be the value of limit? We are trying to understand the concept of limit, right? So what is the number just before 1? So this line is 1, this point is 1. So what is here? What number will be here? It will be lesser than 1, right? Like 0.999 or maybe 0.9999999, right? But not 1. This number, whatever this number is always lesser than 1. Sorry, greater than this, lesser than 1. Whatever number is there from here to here is always less than 1, isn't it? But and the numbers from here and towards there is always greater than 1, isn't it? Yes or no? Yes or no?
Yes, sir.
Yeah. Okay, let's again try to
Yes, sir.
understand. Yeah, see, Now, if suppose that there is a number, let's say 0.5, x is equal to 0.5. So if x is equal to 0.5, what is the value of y for this function f of x? This is 1, right? Isn't it?
Yes, sir. Yes.
See, whatever value of x, you put any value of x in here. You substitute any value, you will always get 1, right? We are just trying to understand this function. Okay, whatever value you substitute here, you will always get 1. So this number, so you see that this is approaching towards this side, right? It is approaching towards this side. The value of x is approaching. And similarly, here in this direction, see, the number is always greater than 1. So it can be 1.0000000001. But even at this point, the value is how much? 1. Okay, the value of function f of
Yes.
x is equal to 1. All right, that means either the function come from this side, the value is always 1. It approaches from here, the value is always 1. The value that is closer to this point. So here the function value is same as that of here, right? But at this point, the function is not defined. You understood? Right? So see,
Yes, sir.
when the function is not defined, it was very tough for mathematicians to find the values at that point. That time we use the concept of limit. So we use limit as, we write limit LIM, or LM also we write limit some x tends to 1. Okay, tends meaning is it is approaching 1. All right, that means it is, the function is not 1. Okay, then it is not 1, but it is tending to 1. Okay, it is not 1. Just understand, it is not 1, but it is tending to 1. Okay, so what is the value here? So of the function f of x is equal to what? 1. Isn't it? For this function. See, if x is not equal to 1, because f of 1 is not defined. Not defined. Fine. F of 1 is not defined. But if x is approaching, that means x value here is 1, right? So at x is equal to 1, the function is not defined. But if x is approaching 1, see, x is approaching 1 towards this point from both sides. So it is at x is equal to 1, the value of function is what? 1, right? So f of x is equal to 1. This line is f of x represent 1. Understood? So that's how we write limit. Limit x tends to 1, f of x is equal to 1. Understood? What's the meaning of limit? See, with limit, this symbol will always come. This is how we write limit. X tends to some value. Let's say x tends to a. That means this point will become a. Okay, at this particular point we are talking about. Got it?
Yes, sir.
See, it's a very widely used concept in calculus. Okay, a lot of things are defined based on limits. Mostly, actually, the calculus depends upon limit. Okay, but it is that important, and it is exactly that simple. That means it is just approaching. That means you are going to school. You are just about to reach the school, but you haven't reached the school yet. Understood? It is just,
Yes, sir.
yeah. So that is limit. Okay, we'll try to understand with the help of some of the example. So this is the idea behind limit. What we say is intuitive idea behind limit. Okay, so if the function, it is up, because see, if at a certain point, let's say here, if the function is not defined, it was very tough for mathematicians and physicists to calculate values. Okay, because the function was breaking. That's when the concept of limit came into picture. Okay, so limit is really, really important, by the way. All right, now let's take another example. Let's say some function g of x. Okay, g of x is equal to, okay, let's define this function. It is x square if x is not equal to 2 and it is 1 at, sorry, x is equal to 2. Can you plot this graph? Just try to plot this function. Okay, just try to plot, draw x, y, x, and try to plot this function. This is, by the way, parabola. We just studied in conic section, right? So all the conic section are also a function, isn't it? But we are not studying that calculus. We were just studying the geometry of those things, right? So that's why it is called, it's a part of coordinate geometry. Okay. So if you are writing an equation, y is equal to 4ax or 4a y square is equal to 4. This is also a function, isn't it? But we are not studying this in terms of calculus. We had studied in terms of geometry, how the geometry will look like. Okay. Right now, just try to plot this one and we will understand it. We'll try to understand limits. Okay, let me do it. So let's say, again, as usual, this is our y-axis. So let's draw it here. Y, and let's say this is x. So y and x. We already know the shape of the function, right? Like substitute if g of 0. If you put x is equal to 0, that means which function it will follow? It will follow this, because everywhere it is x square. So this means 0 square, right? So this will be equal to 0. So at 0, the value is 0. Okay. At 1, let's write down g of 1 will be equal to 1 square. That is equal to 1. Okay. So 1 means 1 square. All right. So here, sorry, this side, 1, 1. Now, if you substitute g of -1, you'll get -1 square, which is again equal to 1, right? So this side. Okay. Now, let's substitute 4 or 3 or any other value, g of something. Tell me one value, 1.5 or something. Let's say 1.5. So this will be equal to 1.5 square, and that will be equal to 2.25, right? So some values. Okay, so g, that means if you try to plot this function, it will look something like that. Let's see. Okay, we already kind of know the shape, that's why we are drawing it like that. Okay, so kind of like this. Okay, so at x is equal to -1, the value of y is 1, right? So this point, this line is y is equal to 1. Okay, so this is 1 and this is 0, 1. Now at 2, at x is equal to 2, if you put x is equal to 2, we don't know the value of function. It is 1. It's given that the value is 1 at x is equal to 2. Okay, that means it will not follow the above equation. It will follow this, right? Because x is equal to 2. So at x is equal to 2 only, let's try to extend this function. Suppose the function is somewhat like this. Okay, so let's zoom it here. So at x is equal to 2. So at 2, the graph should not be continuous. Okay, there is a break in the graph. So let's erase it here. So there is a break. That means the function, the value at x is equal to 2 is how much? 1. Here, the value is this much. So if you draw g of x, that means this is the value. This should be the value. At x is equal to 2, the value of function is 1. It should be 4 if you follow this curve, but at x is equal to, let's say, -2. -2, the value is same because it's not given in the problem. It's given that this function, right? So this is second example. Now g of x, it is always x square. It is always x square, but at x is equal to 2, the value of function is 1. Okay, that means this is the curve. So there is a break here, right? We all can see there is a break. So the function is not continuous. Function is not continuous at x is equal to 2. There is a break at x. We are going to study about continuity as well, but I'm just continuous and not continuous, meaning simply in a layman's term, I can say that if there is a break in graph, or you can draw the graph without lifting your pencil or pen, whatever, then the curve is continuous. Or if you have to lift your pen, that means it is not continuous. Understood? That's the very rough idea of continuous function in a 2D graph that you can draw, but not exactly like that. We'll again going to study. So this function is not continuous, but again, if you talk about the limit, so if the function approaches 2, okay, from both sides, okay, so here the value of x, this side, the value of x is always greater than 2. Here the value of x is lesser than 2. But if we come closer, so the value of x here is 1.99999 something. Okay, here it is 2.0000001, something like that, right? So at that particular point, what is the value of function? So at that particular point, the value of function is how much? Almost 4. Almost 4. It is not 4, but almost 4. We can use a calculator to understand it. So if we have a calculator, I don't know if I have scientific calculator here. Okay, do you guys have scientific calculators? Anyone? It's always interesting to do that. Okay, let me check. Scientific calculator. Okay, so what do we have? X square, right? So 1.9999 squared, right? How do you use square function? Squared. Okay, so how much is the value? It is 3.99. Can you see the calculator, right? So
Yes.
again,
Yes, sir.
so see, it is not equal to 2, but it is almost closer to 2. So let's write down here. So if x is equal to 1.9, let's start from 1.999, three nines, right? So where is that? Okay, so we have 1.999 square. If you square this, how much we are getting? 3.996, right? 3.996. Y or g of x, y which is equal to g of x is, that means let's write down y at 1.999. We're getting 3.996. Okay. At x is equal to 1.9999999. 79. So y is at g of 1.1234567. How much will get? Anyone? So 1.9999999 square. Sorry. Square. 3.999996, right? 3.999996. Okay. Now, so these are the values which is to the left side of x is equal to 2. values to the left of 2. Okay, left means this side. Just try to understand. Left is, that means this side. That means the value is smaller than 2. Now the values, those are greater than 2 is to the right side, right? So values, now let's write in red, values to the right. Why I'm writing left and right, we will understand that. Left here or right of 2. That means the value is greater than 2. So x is equal to, let's say, 2.0001. Okay, so y is equal to g at 2.0001. How much will be the value? So let's substitute it here in the calculator. Okay, so 2.0001 square. Okay, sorry. How much we are getting? 4.0000, 4.0004. Okay, so 4.0004 approximately. X is equal to 2.000001. So y at g, x is equal to 2.000001. So how much will get? Let's see. Okay, so 2.123456 square. Square it. We are getting 4.666 okay. 4.000004. Now you see all the values are tending towards what? All these values. See, this is the value closer to x. This is the value of x which is closer to 2. This is the value of x which is closer to 2 again, right? So now if you see the value of x which is closer to 2, right, these values, and the value of y is approaching 4 because of the function x square, right? At x of any value is follows x square. Understood that point, right? That means the values, the value of x closer to x is equal to 2 approaches y is equal to 4, or y or g of x you can write y is equal to 4, right? That means it is following the function x square, y is equal to x square. Understood? So that we call tends. Okay, so we can write limit x tends to 2 g of x, okay, that is equal to 4. Okay, why? Because we can write limit x tends to 2, g of x is what? What function is g of x? This is x square, right? So x square, because at x is equal to 2, just try to understand, at x is equal to 2, the value of function is 1. So when it is approaching 2, the value of function is what? X square. Okay, so x square. Now if you put x square, so you just put x is equal to 2. So what you will get? 2 square, which is equal to 4. Now you understood why limit x tends to 2, x square is equal to 4. Okay, it is, the value is tending towards 4. It is not exactly 4. Understood? Limit x tends to 2, f of x is equal to 4, but not. But try to understand limit, but at, sorry, let's write like this, g of 2 is not equal to 4. Okay, this is equal to 1. Understood? According to the given function. Did you understood or not? Yes or no?
Understood, sir.
You are getting the idea what it is? See, these are just the ideas of limit. Okay, just to understand what limit is actually. Okay, now there are two types of limit. I told you, see, this value I have written from left side, right? If you can see the pointer, left and right. Left means the value which is lesser than 2. Right, which is the value greater than 2. That means right will approach in this direction, left will approach in this direction, right? So the values which is to the left hand side, we call it left hand limit. Okay, so left hand limit. Okay, left hand limit meaning value closer to some point, to the given point. Here the given point is 2. Given point, value of closer to the given point, to the value to its left, or smaller value. Okay, and it is represented by limit x tends to 2 minus. Okay, the left hand limit is represented like this, g of x. Okay, and the right hand limit, because this one is called the right hand limit because it is approaching from the right hand side, the greater value. Okay, so the right hand limit, right hand limit, the value is greater than the given point, the given value, this side the given value, and approaching to the point from right side. Okay, that means the value is greater, of course, and it is represented by limit. In this case, we are writing for this example. Okay, for g of x, we are writing only. Here also we have written for g of x only. Okay, usually instead of 2, you will get a point, let's say a. Okay, limit x tends to 2 plus g of x. Okay, understood? Now, when the function is continuous, if the now understand this, the function is continuous, the function is said to be continuous. The function is said to be continuous if limit, the left hand limit, so left hand limit, this is right hand limit, so it is called RHL. This is the left hand limit, so it is called LHL. Okay, so if the left hand limit is equal to the value of that function at that point, let's say the point is a, is equal to right hand limit. Okay, okay, so in terms of mathematics, we write it as limit x tends to a minus of some function f of x should be equal to f of a, and that should be equal to limit x tends to a plus f of a. That means the function is continuous if this criteria is fulfilled. Now, in case of g of x, when we are drawing this parabola, in this parabola, if at x is equal to 2, the value of this is equal to 4, that means y will be equal to 4, then this limit will be continuous. This function will be continuous. Right now, the function is not continuous or discontinuous. Okay, discontinuous at x is equal to 2. Everywhere else, the function is continuous. Okay, see why we are talking about continuity, because the name of chapter is only limits and derivatives. So why should we study about continuity, continuous function? The thing is, if the function is not continuous, it is not derivable. Okay, the derivative of that function is not possible. Okay, the function can only be we can only take the derivative if and only if the function is continuous. So that is the criteria for derivatives. Okay, that's why we are studying continuity. Okay, so hopefully you got this idea. We are not solving a problem. I'm just trying to give you an idea. Okay, so again, I'll just give you this idea. So this is x. See, we are only studying function in two variables. Okay, function of one variable. Sorry, not two variables. X. Don't say that x and y are two variables. Okay, two different variables. X. It is function of only y is only function of x. So function of one variable we are studying, single variable function. So let's say there is some function. We don't know about this function. Some function, some random function. Okay, some random function we have. And we have to find at, let's say this is the point. This function is defined as y is equal to f of x. This function is defined as y is equal to f of x. Okay, that means this is f of x. How it is varying. So at a point, at a given point, let's say x is equal to a. Okay, the value of function is going to be f of a, right? At this point, that means the coordinate of this point will be what? A comma f of a, right? Isn't it? This point P. Let's say this point, some point, the coordinate is a comma f of a. All right. Now, when we are talking about limit, okay, left hand limit meaning if the function, the value of function is not a but approaching a. Okay, so left hand limit you will write LHL will be limit x tends to a minus, okay, a minus f of x. See, this is a left hand limit. The right hand limit you will write as limit x tends to a plus f of x. Plus meaning the value is greater than x. That means, see, left hand limit meaning is it is this side. The value is somewhere around here and it is approaching a, but it is not a, right? And if the value is here and right hand limit is approaching this side, it is not a, the value is something greater than a. Here the value is something lesser than a. That's why the symbol represents. Okay. Now here, and the value of function at x is equal to a is f of a. So if these three criteria are matching, means if these three criteria are equal, that means we say the function is continuous. And you can see from this graph, from the given graph, at x is equal to a, the function is continuous, right? Because you can draw the function without lifting your pen, isn't it? That means there is no discontinuity here, right? So from here you can say limit x tends to, or in short, let's write left hand limit is equal to the value of function at that point f of a, which is equal to right hand limit. Understood? Then we say the function is continuous. Function is continuous at x is equal to a, and a is the given point. So at this point, we need to tell whether the function is continuous or not. Understood the meaning of different continuity and limits? This is what the meaning of continuous function is. Understood? Same thing again you are going to study in 12th standard. Okay. So it's better you make a habit of here itself rather than just substituting the values. In your NCERT book, you will only substitute the values of all the problems. It's always important to understand what you are studying right now. Okay, rather than just substituting the value and getting the answer. Okay. Okay. So now let's have, today we'll have just the idea. Okay. Derivatives will cover in next class. Let's solve some of the problems based on limits. Okay. Question number 1. Let's say, find out the limit x tends to x tends to 0 of the function sine x. Sine x is equal to what? Find out. Tell me.
0, sir.
0. Yes. You just substitute limit x tends to 0. It is sine x, right? Okay.
Sir.
Okay.
0, sir.
So you just substitute sine 0 and you'll say the value is 0 because sine 0 is 0. Okay. Okay. Fine. See, it is, see, in your book, this has been defined like this. Okay. But this is very bad idea to solve like that. You have to understand why it is equal to 0. Okay. Anyway, we'll see that in upcoming classes. See, limits mostly in 3 classes will finish limits and derivatives. Okay, hopefully it won't take much more than that. So this is limit. Okay, next one is, let's say the function y is equal to g of x, which is equal to, or let's directly write y, g of x is equal to cos x plus sin x. Okay, cos x plus sin x. Cos x plus sin x. Find limit x tends to pi by 2 of g of x. Find out.
One,
Tell me
sir.
just how you will just substitute the values here, right? That's
Sir.
what you will be doing, right? Okay. Okay. So as of now, that means you have understood. See, one more concept what we can take out from here is, see, if limit x tends to a, some function, let's say h of x. Okay, and given h of x is equal to g of x plus f of x. Okay, so this value is equal to 1, right? So I hope every one of you have understood. You just need to substitute the value, right? Like cos pi by 2 plus sin pi by 2, right? So cos pi by 2 is 0. This is equal to 1. So this will be equal to 1. Let's understand the concept. See here, this. So you will substitute it. So limit x tends to a, g of x plus f of x. Okay. So you can write limit x tends to, you can separate the limits for addition or subtraction. Okay. G of x plus or minus limit x tends to a, f of x. Understood?
Yes, sir.
Okay. So this is limit x tends to a, h of x. Got it? So this is one of the property of limit. Write down property 1. All right. Okay. Let's come to, do you have idea of log? Okay. Before we go to log, let's talk about some of the indeterminate forms or indeterminate, what we can say. Yeah, let's write indeterminate forms. Indeterminate forms. Okay, so some of the numbers that we say is indeterminate is 0 upon 0 is indeterminate. Okay, any other numbers? Infinity upon infinity is indeterminate. Infinity itself is undeterminate, right? So infinity minus infinity is also undeterminate. Minus or plus, whatever you want. See, it is not equal to 0 because we don't know the infinity. For some, infinity can be this. Even though we can write it something, for some infinity it can be 999 to the power 999. How can you say which one is greater? We cannot, right? Because we don't know the end, isn't it? Because here also it is infinite numbers. So infinity minus infinity cannot be 0. Understood? Because there is no such, there is no one infinity. Infinity is also set of values of numbers, right? Isn't it? Like where pi ends, 3.14 dot 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 dot. Infinite numbers are there. Okay, there is no, it cannot be determined. So infinity is just a symbol to represent. Infinity is a set of number. It's not just one particular number. Okay. Okay, comma. Okay, now if you even if you multiply 0 with infinity, that is also indeterminate form. Or if you take 1 to the power of infinity. See, 1 to the power of anything is 1. We know that for real numbers, but that is also not always true, is it? Now 0 to the power of 0. What is, see, 1 to the power of 0 is what? 1. Or anything to the power of 0 is what? 1. But is 0 to the power 0 1? It cannot be determined. So this is also indeterminate form. Again, infinity to the power of 0 is indeterminate form. What else? Anything else can you think of? Let's say infinity multiplied by infinity is also indeterminate form, right? This is also indeterminate, isn't it? Or infinity to the power of infinity is also indeterminate. Or 0 to the power of infinity. We have already written, no? No? Okay, 0 to the power of infinity is also undeterminate. So we cannot plot a function at infinity. That's why it is undeterminate form. So these are some of the, unlike 0 by 0 form, the first example that we can see, like these two functions, y is equal to, let's say two functions, f of x is equal to, let's say x square or x, and g of x, okay, g of x is equal to x square upon x. R is f of x is equal to g of x, is it? Yes or no? Huh? Is sorry, if y have written f, it is f of x equal to g of x, is
Yes,
it or
sir.
not? Why?
Yes, sir.
Because x square divided by x is equal to x, sir.
Okay, so you cancel this and you will get x, right?
Yes,
Sir.
sir.
But it is not true all the time. Why? Let's understand. Okay, let's try to understand it here itself. Okay, okay, so let's try to plot both the functions. Okay, sorry. See, let's say this is y and this is x. So if you so here y is equal to f of x and y is equal to g of x. So first let's plot f of x. So f of x, y is equal to x. That means for all values of x, you have all values of y. So whatever is the value of x, you are getting the value of y. Now let's plot g of x. So g of x is also kind of similar, but at x is equal to 0. Sorry, yeah, at x is equal to 0, the function is not defined, right? So g of x is not defined when x is equal to 0. You see? See, the denominator must be defined, no? So denominator cannot
Yes.
be 0. If x is equal to 0, this function will become what? 0 upon 0, right? Is it or not? At x is equal to 0, at x is equal to 0, g of 0 is equal to what? 0 upon 0. And 0 upon 0 is what? Indeterminate form. So f of x and g of x are not equal functions. Because at x is equal to 0, they have their differences. At x is equal to 0, f of x is defined, but g of x is not defined. So at x is equal to 0, f of x is defined, but g of x is not defined. Got it? Understood or not? Huh?
Yes, sir.
Okay, let me
Yes, sir.
show.
Understood, sir.
Okay, let's understand it here. Okay. Oh. So we have two functions. Let's say y is equal to y is equal to x, right? This is y is equal to x, right? Now let's say another function y is equal to x square sorry, divided by x, right? x. X square upon x. Now this function, this blue function, if you point at 0, the value will never be, it cannot be defined at x is equal to 0. See? You see what you're getting at x is equal to 0? Huh? Yes or no? Can you see this?
Yes, sir. Yes.
See, at x is equal to 0, it is undefined. Understood?
Yes,
So
sir. Yes, sir.
both the lines are same, right? The blue line, if I turn off this line, you will only see the red line, which is y is equal to x. Okay, if I turn off this also, turn on this. So at x is, see here, you cannot see because the limit will be approaching, no? Limit from this side, from left side, right side is approaching. But if you point your finger at 0, it will show that it is not defined. Okay, understood? Okay.
Understood.
So that is the intuitive idea of limit and continuity. So we'll carry on this next Monday. Okay. So Monday, Tuesday, probably we'll finish derivatives and limits as well. There is nothing. See, if you understand the concept behind limits and derivative, that's it. Because in your NCERT book, see, in the beginning, they have given some concepts, which is really, really nice to plot the function and all. But later on, problems are not based on that. So yeah, we'll see that. Okay. Thank you so much. Bye. We'll
Thank
see
you,
you
sir.
next Monday.
Thank you, sir.